In this series of lectures, we introduce some basic and important concepts in calculus. As an entry-level course, we often adopt approaches that are intuitively clear but might not be mathematically rigorous. In particular, we will not use the famous epsilon delta language. In this video, we'll look at something called implicit differentiation. Let's look at examples to demonstrate how to do implicit differentiation. Okay, example 1. Here we have an ellipse that's given by the equation x squared over 8 plus y squared equals 1. And what we want to do is we want to find the tangent line that passes through the point 2, 1. Now, obviously, point 2, 1 is on the ellipse. Now, because we already know the point, what we need to do is we need to find the slope. That's all we need to find out. Okay, so how we do it? One way to do this I call method 1. So what we need to do is you can just try to explicit. Okay, so what we're going to do is find explicit expression of the function y equals to yx, right? And then the slope is just take the derivative. Okay, when you look at the graph has the upper part and the lower part. The point is on the upper part. The upper part of y is non-negative, right? Then from here we can solve the equation. If I use here, I can solve y squared over 2 is 1 minus x squared over 8. And from here, I can get y squared equals 2 minus x squared over 4. And then I get y is just the square root because I look at the up half. So y is non-negative, right? So I just choose minus 1 minus x squared over 4. Okay. Now, what I wanted to do is want a slope, right? So this is what we want to find. So the slope of the tangent line is equals to y. You take the derivative at the point 2, right? Take the derivative at the point 2. At the point, so at the point 2. So that's what we want to figure out. Now, how we take the derivative? We use the chain rule. So this can be written as g composed with 2 minus x squared over 4. And my gy is equal to the square root of y, which could be written as y to the 1/2, right? Could be written as y to the 1/2. And then if you take the derivative, remember, if you take the derivative of a power function, what do we do? From the previous video, we know the y, so this is 1/2, you pull this one. Okay, so x to the alpha, if you take the derivative, this is alpha, x to the alpha minus 1. So this is what we did before. Okay, so it's 1/2 y, 1/2 minus 1, right? So it's negative 1/2, so 1/2 y to the negative 1/2. So that's just 1/2, 1 over the square y. Okay, so then I get the derivative of this, right? Will be just g prime 2 minus x squared over 4 and times 2 minus x over 4 and take the derivative. So this is chain rule, right? We use the chain rule. Okay, well, then this equals, if I plot this, you see I have the derivative derived here, right? Okay, so this just be 1/2, 1 over the square root 2 minus x squared over 4. And you take the derivative of this. Here's a negative x squared, the derivative of 2, and cancel with the 4. So we get just negative x over 2, right? Negative x over 2. Now you plug x equals 2 here, right? So you let x equals 2, and then you just get x over 2, you get 1, right? So this will be 1, this will be 1. So you get is negative 1/4. Get a negative 1/4, right? Negative 1/2. You get is negative 1/2. So this is the slope of the tangent line. Well, here we use the explicit expression of y. Okay, so then of course we can write out the equation of y minus 1 is negative 1/2 and x minus 2, right? Now here, of course, the reason we can do explicit expression is, after all, the equation itself is not that complicated, so we can just explicitly solve it. But here I want to introduce the second method, which is more convenient to use in many ways. So this is what we call implicit differentiation. Okay, so we are going to look at implicit differentiation. Now, what is the idea? the idea is we're not going to write out the explicit expression, okay? So we just keep in mind. So we know y is a function of x, right? Y equals to yx, right? Y equals to yx, but we are not going to take the trouble to write out. Okay, so we just consider, you see, this is x squared over 2 and plus y function x squared over 2 and 2 equals 1, right? Okay, now, because all I want is I just want to find the derivative of y at a point 2, right? Okay, so what we should do? Let's take a derivative on both sides. Let's take a derivative on both sides, and this one is 0. Of course, with respect to x, this is d dx with respect to x. Take a derivative with x. Now, what do we get here? So the derivative of this one is just x over 4. Now, what's the derivative of this? We use the chain rule. So what is the derivative of square over 2, right? Take the derivative. 2 is a constant. Y squared this, take the derivative. We know this is just the g composed with y squared, yx, right? Take the derivative. And here y is the y squared, right? Okay, so then we know the g prime evaluate yx and times y prime x. Okay, so and the g prime here is just equal to 2y, right? It's 2y. Okay, so then we get the derivative of this is 2yx times y prime x, right? Okay, so that's what we get here. Right? So that's what we get. We get the derivative of the term by chain rule again. By chain rule, we know this just equals the yx. This is 2, this is 2, they cancel with each other, right? We have two copies, they just cancel each other. And times the this is y prime x equals 0, right? Y prime x equals 0. Okay, so from here, what do we get is, let me rewrite it. So for x plus y and y prime x equals 0. Now we can just plug in 2 because x is 2. So x, this equals 2, and y equals 1. And from here, we just quickly get the y prime x is negative 1/2. So you see, it's the same thing as we get from the previous method by explicit writing out the expression of yx. But obviously, you see, this one is it's more convenient, right? So this is called implicit differentiation. So without explicitly write out the function, we just take the derivative and apply the chain rule. Okay, now let's use another example to further demonstrate the advantage of this implicit differentiation. Here again, we have a graph which is given by a more complicated equation. You see, for this equation, and there's no way I can really write out, right? So you see from here, it's not easy to find explicit expression, right? Okay, so definitely it's not easy. So it's okay. We just go with the implicit one, right? So it's okay. Let's go with the implicit one. All right. Okay. So what shall we do? Again, here we are looking at the point is 1, 1, and we want to find is the slope, right? Okay. We take it. So let's look at the procedure. We have x to the 4 and xy and plus y to the 4. So here, keep in mind the y is a function of x, right, to the 4. Okay. Okay. Now. If you like, you can put that into the expression. You say, okay, I is x, a function of x, and a plus a function of x to the power 4, right? So this equals 4. I don't really know the expression of y. Everything is implicit, but it doesn't really matter. I just take a derivative on both sides, and this one is 0, right? Okay, now here I take the derivative of this. This will just 8 x to the cube, right? And this, now let's take a derivative of this one. So this is yx. This I use the product rule, right? Use the product rule. You get is yx and then plus x y prime, right? Okay, so it'll be y plus x and y prime. So here I omit the dependence on x. And then now you take the derivative of this guy. So what's the derivative of this guy? This is just g composed with yx. And my gy equals y to the 4. Okay, so now if you do the derivative by chain rule, right? By chain rule, the y to the 4x, you take the derivative by the chain rule, you can get, you see this one, you know the gy, if the y to the 4, so the yx cube. All right, so this is just 4 y to the cube and times y prime x, right? Okay, so then we put that, and then this is, we put is the 4y cubed and y prime, and this equals 0, right? So this equals 0. Okay, now let's plug everything. So it's 1, 1 here, right? So this one will be equals 8. This will be 1. This will be just 1 prime because you had x with 1. And this will be y equal 1, so it's 4y prime, right? So everything, if you combine them together, you will just get 8 plus 1 plus y prime plus 4y prime equals 0. And this gives me the y prime, if at 1, will be negative 9/5. So this is the slope. This is the slope k, right? So as long as you get the slope k, you just get the equation is x minus 1 equals negative 9/5 and y minus 1, right? And y minus 1. Okay. Let me write this. So it will be minus 9/5 minus 9/5 and y minus 1, right? Y minus 1. Okay. All right. Okay, so now you see the advantage of this implicit differentiation. All you need to do is just take the derivative of the equation without explicitly solving the equation. Okay.